Good morning, good afternoon, good evening, depending on when you're watching this video. So for today, we'll be looking at Seaborn. Okay, so I told us immediately after Matplotlib, we'll be looking at Seaborn. Now, what is Seaborn? Seaborn is the main library that we use for visualization of data. Okay, so after your data has gone through the process of importing it into Jupyter Notebook, you use pandas to do data cleaning or data manipulation, data preprocessing on it. Then the next thing to do is to do Seaborn. You use Seaborn to carry out explosive data analysis. That is, you try to explore each section of the data set and see what are they trying to say in this particular column, or you try to understand your data by visualizing it. Either way, okay, or you visualize it in order to communicate the data to a layman or to someone who doesn't understand what the data set is all about. Okay, now we'll be looking at different kind of plots. So we're looking at distribution plots, we're looking at categorical plots, and we're looking at matrix plots. Okay, so distribution plot, categorical plot, and matrix plot. Now, the first thing to do is to import the library. Initially, I told us that we use Seaborn in Matplotlib, right? So now I'll be showing us how the library actually works. Okay, so the first thing is to import the library, import Seaborn as SNS. Okay, so when you import a library, you import as SNS. Okay, so what we'll be using throughout this video is SNS. So anytime you want to visualize a library, a data set, you use SNS. Okay, so now we also use Matplotlib here. Okay, I think there's a section where we do Matplotlib. We've done Matplotlib in the previous class. So for this class, we'll be looking at Seaborn. Okay, so I'm just going to run this. Okay, so in case you import Seaborn as SNS and you're having an error, like library not found, all you have to do is to search for that error on Google, or you have to install Seaborn. How do you do that? You open your Anaconda prompt on your start menu, search for Anaconda prompt, press enter. Once it's open, type in install pandas, or import Seaborn, or pip install Seaborn. You could search on the internet. They will show you a guide on how to do the installation. So once you just put pip install Seaborn and press enter, make sure that your system is connected to the internet. There you have access to it. Okay, so now let's talk about distribution plot. But before we look at distribution plot, let's look at the inbuilt data set. All right, so the next thing to do before we start looking at different kind of plots is to look at the inbuilt data set in Seaborn. Now, Seaborn comes with different inbuilt data sets. Okay, so if you type sns.get_dataset.names, you're going to have all these data sets. So these are inbuilt data sets. So if I say sns.load load, let me put iris. I'm going to copy this one, and I run this. Okay, sorry. Load. SNN.load dataset. Sorry, I didn't put this actually. Okay, so let me just call this SNN. I'm going to give this h equals to. I'm just going to put h here. So when you run this data set, you are going to have this. Okay, so what we're going to do, we're just going to do a little play. We're going to copy different kind of data sets and run them and see what it's going to be. So I'm just going to put in here this. Let me copy from the top. Brains network. It's still loading. When you say asterisk here, it means it's still loading or still processing. Okay, so this for the taxi data set. So now let's look at the last one. I'm just going to, so you could play around with more. So this for brain networks. Okay, so these are the different invis data sets. So how do you load an invis data set? You give it a variable. I just give it a random variable h, and I say sns.load underscore data set. Then any of these data sets you put in, let me try the last one, dots. So any data set you put in is going to load for you. Okay, so this for dots data set. Okay, now moving on, we're going to start with distribution plots. So for distribution plots, we are going to work with disk plots, joint plots, pair plots, log plots, and KDE plots. So the first thing we are working with an invis data set called fibs. So if you come in here, you see we have fibs here. So that's the data set we're working with. So if I say fibs, I just give it the same variable name. But I could just say TIS. Let me just give it TIS. So if I run it, it's the same thing. So I just give it a variable name TIS, snn.load dataset tips.head. So that is it. Then snn, okay. So if I say for this plot, looking at distribution plots, so if I say a distribution plot for total bills, I'm picking a column from the data set. The column from the data set is total bills. So I'm picking a column called total bills. So I'm just going to say tips, but it's going to supposed to be TIS. So tips.data set. Okay. So this is giving me a distribution plot. When you see this plot means distribution plot. Okay. So it's going to give us a distribution plot of the total bill ranging from 0 to the other side. Okay. So now let's look at joint plot. So for joint plot, it has different kinds. Okay. For joint plot, you could have scatter, reg, RESID, KED, HEX, hexadecimal. So let's run this guy. So when we run this guy, we have the first line of code. Say sns.jointplot x equals to total bill, y equals to tip, and data equals to tips. Then the kind is scatter. Now the data here is tips. Did I change it? I changed it from tips to tips. I guess I just have to put it back. Let me just change it back to tips so that we don't confuse ourselves, because I've been using tips all over. Okay, so let's just go back to this place. So sns.jointplot x, value of x is total bill, that is the total bill. The value of y is tips. Note that the two columns that we picked in here, that's the total bill and the tips, are floats. That is, they are numbers. They are not strings. Don't forget we talked about strings and floats in Python crash course. Okay, so they are floats. So that's why we're able to, like, we are plotting numbers against another number. Okay, so x, y. The data is tips. That is, the container holding this data set is called what? Tips. Tips is the container hold. That's why we said data equals to tips. Then the kind. Now the kind could be scatter, reg. So now let's look. So this for the first line of code says scatter. So this is scatter plot showing the distribution of total bills ranging from 10 to 50. Then the tips ranging from 2 to 10. Okay. Then we have the hexadecimal. So the hexadecimal shows okay, at this point there are more likely total bills and tips in this region, okay, than all this faded part of the region. Then we have the last one, which is regression, reg. The kind here is reg. This one is hexadecimal, this is scatter. So for reg, that's regression. We have a linear regression. Okay. So now let's move on to the pair plots. For the pair plots, we have pair plots will plot pairwise relationship across an entire data set for the numerical column and support a color argument for categorical column. So now this is how pair plot works. Pair plot is used to show the relationship between the data set, between the entire data set, okay? But it's mostly for the numerical columns of the data set. okay, the numerical column of the data set. Okay, so now let's look at this. The first one, we see sns.peerplot tips. Okay, if you do SNS, if you copy this, let me copy this, do this, yeah, run this, and let me run this alone. Let me run this alone. You notice that there's difference in their color in the same chart. There's difference. See the difference between this and this. Now this one doesn't have legend. This one has a legend. The legend is the male and female, while this doesn't have a legend at all. So the difference is that we did a peer plot, right? Data we are working with is tips. Data we're working with tips. Now the EU here is used more of like a filter. Okay. So if I say I want to filter beans and stone, how do I differentiate between the beans and stone, even though they have the same shape and the same thing? So that's just how this EU work. So you could just pick a column from your data set. Okay, like this is the data set we're working with. This is the data set we're working with. We've plotted the entire data set. But something unique in this data set is the sex, that is the male and female. Okay, is unique. That is categorical. Even the smoker is either yes or no. Is even the day without Monday to Sunday. The time is unique. Okay, so you could filter with each or any of this column as it pleases you. Okay, so we have now the palette. The palette has to do with the color type, just the way we have rainbow colors, like different kind of colors. So my first assignment for us is to Google or research on different kind of colors we have. That's color palette. You could just search Google the color Seaborn color palette or Seaborn or palette in Seaborn. Color palette in Seaborn. You could search for it on Google and you have seen series. Now we've seen color one. We're going to see some. You see set 1 and set 2. I think I've seen that before. Now let's look at rock plot. Rock plots are actually a very simple concept. They just draw a dash mark for every point on a univariate distribution. They are the building block of KDE. That's the kernel density emission plot. Okay. So SNS rock plot tips. So they just show a simple dash between the every point of emission. So you could do more read up here. You could click here to do more read up on kernel density emission plots. Okay, so this rock plots just show different dash points between the beginning of the like initially, let's say we have a bar plot. Initially, if you have a bar plot, if this is the bar plot, it's going to go up and to the top and show us the limit. But this just shows the starting point of the value of the total bits. Okay. Then we have our kernel density. So you could do this together, right? That's the KDE plot and the rock plot together. When you do it together, you have something like this. So in a bar plot, if you have a bar plot, you'll be able to say, okay, this is from here to this is going down, the box is coming down here, right? But with KDE, it shows you from where to where so you could know that, okay, from 2 tips, the tips here has more 2 here, the tips here are like 2. That is in the data set is trying to say that, okay, how many times are people giving tips? Like how much tips are people giving? Or is it how many times are people giving tips? So I think twice, or let me check the data set to confirm, please. So because also note that data understanding is very important. If you understand your data set, it's very easy to interpret it. So the tips now, we have 3, we have 1. Okay, so it shows how many tips have been given for that particular. So for like 2 like has the highest. Okay, now we could do the same thing for total B. Now for total B, we see between the range of between 10 and 20 has like the highest. total bill, that is the value. Okay, now let's move to categorical data. Now for categorical data plots, we are talking about categorical data. Now let's look at this our data sets. This is the data set we are working with. Now from this data, from each of these columns, which of them has a categorical data? What do I mean by categorical data? Categorical data data that, as the word implies, categorical. Like for gender now, we have male or female. If there's a question, we have either yes or no or false, or we have true or false. Okay, like for days of the week, it has a beginning and an end. For the time, we have either breakfast, lunch, dinner, or brunch, either way. Okay, so now let's talk about the different kind of plots. So we have bar plot. So you could, if you want to show your data, if you want to show a categorical plot, you could use bar plot or count plot. So now let's look at it. So for bar plot, you could say SNS.bar plot, that is X is the gender, that's the male and female. Y is the total B. That is on the y-axis we have the total B. Then the data we're working with is what? Tips. Don't forget, if you don't put this stuff, it won't give you it won't know what you're talking about. It might think you're working with another data set. So it's best to put in this. In fact, you're going to throw us an error. Okay. So we're working with SNS.bar plot. X is the sex, Y is the total bill, and data is our tips. Now let's look at coloring or styling of this bar plot. So now let's look at count plot. SNS.count plot, X is day. Can you see that this count plot takes in just one value? So count plot, the y-axis is already chosen for us, okay? Because you know when you're doing count, just the way as the word implies, count, okay? If I say count how many times I come to work in a week or in a month, okay, by just days of the week. So the moment I put days of the week, it should be able to count, okay, for Sunday or for Monday in a month, you came to work like 4 times or 5 times. Just that's what happens here also. So like this one now, for days of the week, the X value is already chosen for us. It's essentially the same as the bar plot, except that the estimator is explicitly counting the number of occurrence. That's why we already only pass the X value. So we're only passing the X value because the count, as the word implies, has already counted. So like Thursday now, the count is like over 60. For Friday, the count is below 20. For Saturday is the high, that is above 80, and why Sunday is between like 70. Okay. Then we have the so now let's look at the design. So we could do spine. So the moment you use spine, you remove the top and the left spine. Okay, the spine I mean is this line, the line here and the line here. Okay, so if I say SNS.setStyle tick, okay, count SNS.count plot, this is the count plot, X data, then SNS.this spine. So the spine is going to remove the top and the left and the right, and the right span, that is the line here and the line here. Okay, so to remove the left and the bottom spine, you have to say SNS.this spine, the left true, bottom true. The reason is because when you say this spine, yeah, by default, left and by default, the right and top are true. By default, right and top are true. Confirm from here, you see right and top are true by default. That's why you have that's why once you just put SNN.this spine, the right and top are true by default. Because on the normal chart, this is how a normal chart is supposed to look like. You're right, normal chart. That's why for the left and bottom, if you now say true to them, then that means it's going to remove it. Okay, so now PLT dot now we are using what here? What are we using? What library is this? If you can guess it right. So this is a matplotlib plt.figure fig size 6,5. Okay, that's the matplotlib. So now we're saying SNN.count plot X equals to sex data equals to tips. So now here we've used what we've used so this box is having a height of the width of 6, height of 5, or either way around. I don't know if I'm mistaken. Okay, 6, 6. Okay. So let's make it 10. Let's see which one is bigger. Okay, so now the height is 10, while the width is 6. So let me just come down here and comment width and height. All right. So now let's move on to the next one. Okay. So the next is LM plot. Now the LM plot, you could do more read up. Okay, now palette color type, check Seaborn color map. Okay, now I've dropped a link here. I already did the assignment for us. So if you could check this link for the color palette. I was talking about color palette in Seaborn. You could check this link for more color palette. So now we are looking at LM plot. So LM plot looks like the regression plot. Okay, that says you put in the X value, you put in the Y value. Note that the value of X and Y are usually numerical values. Okay, the total B is numeric, the tips itself is numeric. Now the data is tips because we're working with a data set called tips. That's what we call it. Then the hue, don't forget I told us the hue is like the filter, what you're using to filter it. If I change this hue to this data set, if I change this data to day, let me change it to day, let's see what it's going to be. Let me change to day, what it's going to be. All right, so when I change it to day, I have something like this. So I just filter the entire data set by day. So I have Thursday, Friday, Saturday, Sunday. Now the palette type is BWR. So I told us to check different type of palette. So please check the different type of palette. Now let's look at box plot and Violin plot. So box plot and Violin plot are used to show distribution of categorical data. A box plot shows the distribution of quantitative data in a way that facilitates comparison between variable or across levels of categorical variable. The box shows the quartiles of the data, while the whiskers extend to show the rest of the distribution, except for points that are determined to be outliers using a method that function of the interquartile. Now, before we move on, let me talk about something called outliers. Now, outliers are numbers that are not in range of what you are looking for. Okay, now let's talk about let's say, for example, we did a survey in a company and we know that everybody in this company is between the age of 22 to 20 or to 40 or to 50, or let's say maximum 60, 22 to 60. And when we shared the link out for people to fill the form, somebody puts their age to be 100 or 120 or 150. So that number, that age is an outlier, 100, 120, because it's not within the range that is supposed to be specified for the data set, okay, for our data collection. So that's why it's called an outlier. So now this box plot, just the way we'll be doing another plot. We have the X. Now, can you see that the X here now is what data type? We're working with a string here because we're working with days of the week. Then the value here, total bill, is the numeric value. While the data is tips, the hue is day. That's what we're using to filter. The palette set 1. Yeah, I told us about set 1. So now all these points where we see this this dash, they are called the outliers. Okay, they don't belong to the data set. So on Saturday, the highest is like 40 something. So any other thing outside this they are called the outliers. Okay. So now let's look at Violin plots. For Violin plots, just the way we work with box plots. X equals to day, total B equals to Y, data equals to tips. In what we're using to filter is sex. split, false, palette, we talk about false. So what I'll be speaking on is the split. Now for the split, that is the data that is, this is splitted into two. We could change this to true. If I change this to true, I'm going to have just one, can you see? Just one violin. That is, the left is red, that is the male, while the blue is female. So we could have this, but that's all we're doing down here. So let me just do Control Z here. Okay, so I'm just going to leave it like this. So we could do split equals to true to have just the plot. So from here you could see that the male here has the highest, while the female is the second, because the red is still up to the top. It's close to 60, but not 60. So let's say 59. Okay, so strip plots. Now, strip plots will draw a scatter plot where one variable is categorical. Okay, so now for strip plots, just the way the name implies, it gives a scatter plot. So when you say jitter equals to true, it gives a scatter plot. Okay, let me put jitter equals to false, or did I do it here? I didn't do it here. So let me say jitter equals to false, and I run this. I'm going to have just a tiny line. So I feel this is more accurate because it's not scattered left and right, it's straight. So I know that from my legend here, I know that male is orange, male is blue, female is orange, or yellow, that color you see. And I could say, okay, from here Saturday, that's the male had the highest. Okay, so we could do split equals to draw false either way. Okay, so now we have swarm plot. For swarm plot, it's like scatter plot, kind of, and violin plot, kind of, but it isn't. So don't use it for large data sets. Okay, don't use swarm plot for large data sets because it's going to confuse you. So, like for this kind of data now, we could see Saturday is still the highest, male is still the highest. But I feel this plot best interpreted, because if you check Saturday is still the highest, but how do we know male? This one still confuse somebody that okay, male is still the highest. For violin, this is accurate because I could say okay, for Saturday, male is the highest here, okay, because it's splitted. Okay, but for the rest, this is also accurate. So I would prefer this because it's going to interpret my data very well. Anyone seeing this will know that okay, on Saturday, male had the highest but for this one, it might be difficult because I might have to be like, okay, they're kind of close. I'm not sure which it is. Okay. So now let's try to do, okay, so this swarm plot, don't use it for large data sets. Okay. So moving on to, so we could combine swarm plot and violin plot. So if you combine swarm plot and violin plots, you have this. Okay. So x equals to d, y equals to total base data set, team split equals to true palette set 1. So this is when you combine both of them, you have this. So which is not really nice. Okay, but it's good to just combine and see what it looks like. Okay, and your color palette also matters, because if you have a color palette that brings out the uniqueness, because like this one now, the colors are kind of the same thing, not kind of the same thing. So that's why I encourage us to explore the different kind of palettes we have. So now let's talk about factor plot. So for factor plot is the most general form of categorical plot. It can take in a kind parameter to adjust the plot type, such as bar, violin, stripe, worm, or box. So now we could do factor plot here. Do factor plot. Let's try to see the kind and see kind and equate it to, so the kind, let's see bar and run. So we could do a swarm plot. So you could try this with bar, you change this to box. Okay, we change this to, so factor plot is very flexible. So say violin, I run this. Good. So Factor plus is very flexible, so you could try it with different kind as it is here. Okay, but you could just leave. Let's remove this. So you could have it like this, and when you run it, you're going to have this guy. Okay, so this is actually cool also, but it's not still straight to explain to a layman, because your chart should be able to speak for itself. That's the end goal. Your chart is supposed to be able to speak for itself. Okay, so let's see style. You could say SNN the set theme style equals to white grid. So let's come to LPL. Is that Seaborn? Is that Seaborn? There's no Seaborn. Okay, so the assignment number 2 is to check for the Seaborn theme, the style theme. So if you copy this and put on Google, right? If you take it to one of their websites, okay, so you should take it to their website. So I'm going to likely click on this guy, the documentation guy, and open this guy also. So our assignment is to look at the two. So we have the white grid, we have the option for the white grid. Can you see parameter? We have white grid, we have text, we have white, we have dark, we have white, dark grid. So let me copy dark grid, sorry. So you could check Seaborn documentation. So you can check Seaborn documentation and copy this and paste it here. So I'm just going to paste this guy here, run it. Sorry. So for this is a dark grid. Okay, so this thing is just the background. So I didn't explain it. It's just the background of what you can see here. It's just the background of what you can see here. So if it's white grid, if you come in here and change it to dark, just dark alone, do that here. On this guy. So can you see the dark background? So it's just the background of the chart. So now let's move on to matrix plot. So matrix plot allows you to plot data as color encoded matrix, okay, which is very interesting, and can also be used to indicate clusters within the data. Later in machine learning section, we will learn how to formally cluster data. So that's formal. You look at clustering of color clustering of a table. It's more of like a box. So let's just dive in. So we are loading an image data set called flight and tips. Okay, so this for the tips, this for the data, this for the flight. We are familiar with .ed.tail. Good. So now we're using something called heatmap. Okay, but first let's look at correlation. Okay, now let's read this. Heatmap. In order for heatmap to work properly, your data should already be in a matrix form. The SNS.heatmap function basically just color it in for you. For example, so now let's look at correlation. Now let's check the correlation for correlation matrix for your data set. That is the tips data set. That is this entire data set. The correlation matrix. So it's just going to do a matrix. If you check, the diagonal are always the same thing. And what is here is equivalent to what is here, and what is here is equivalent to what is here, and what is here is equivalent to what is there. Okay, that's correlation matrix. So from here, if we do an heatmap correlation, okay, an heatmap correlation, we're going to have this. So from here, you could see that the darker part is like 0.5. That's just the way this guy is encoded. That's just the way this place is. So this is just the text, and this is just the color aspect of it. You could add the numbers inside. So if you see, we have 0.6, 0.6, 0.49, 0.49, 0.68, 0.68, and everything in diagonal here are the same color. So the correlation matrix to show that your data set are well correlated. Now for the flight data set, we could create a pivot data set, that is to see the entire data set. You know, the flight data set, when we imported it, it looks like this. It's just like this, okay? The passengers, we can't actually see the entire passengers numbers. So we could use a library called the pivot table. So if you say flight.pivot table, then the values are the passengers, the index are the months, just the way we have the index here. Then the columns are the year. Okay. So then you'll be able to see every number. So from January to December, all the passengers that moved. So for 1960, we have 147, no, sorry, 417 in January and so on. Okay, so now let's try to look at this, the heat map for this data set. So if we say PV flight equals to flight, the pivot table, just what we have there, and say snn.heatmap of this, we're going to have this guy. Okay, we're going to have this guy, but it doesn't look so appealing, or because it's kind of the same thing. So let's look at the box. So it's snn.heatmap. Now the CMap maga, it's like the color also. Okay, it's like the color type, just the way we have palettes. So you could check heatmap, CMap type of CMap in heatmap, Seaborn. Okay, you could just copy this code and paste on the internet or Google. You should have, you just see the first thing that comes up is the documentation on this. Okay, now let's talk about cluster map. So for cluster map, we have sns.cluster map PB flight, that is this data set, PB flight. Okay, so if you do cluster map, you're going to have this guy. So the cluster map just show an hierarchy kind of, okay, an hierarchy kind of showing the flow. Okay, so for 400, I think it's January. So for January to okay, between 1949, 1950, 1953, 54, 1951, and so on and so forth, it moves like this. So it's just showing an hierarchy structure, but you could look at this color to be able to know where and where. So for like, let's say the lighter part, so where's the lighter part, which is this part, they're about like 600. So this entire stuff you see here, it kind of explain this entire data set. Okay, so now let's do some color coding. That is, now I told us CMap is also like the it's also like the palette we have in Seaborn. That's the color crayon kind of. So you could check more for it. So now let's look at grids. Grids are general types of plots that allow you to map plot types to rows and column of grid. That this helps to create similar plots separated by features. Okay, so now we're loading an English data set called Iris. Okay, so for Iris, we have for peer grid, we have, for grid, we have peer grid, grid plots, and peer grid. Peer plots, grid plots, and peer grid. We've talked about peer plots. Okay, so let's look at peer grid. So for peer grid, if you just say sns.peer grid, don't forget I told us anything peer is just to show the relationship in the data set. Okay, so for peer plot, we've worked with peer plots. You can go back to watch the video and check for peer plot. Now for peer grid, we have sns.peer grid, which is this data set, which is just like an empty canvas. That's the way we have it in Matplotlib. Okay, but if you now pass in Gmap, okay, if you're now passing something like map, let me explain again. When you say snn.peer plot of Iris, you have an empty chart, because there's nothing, you're not passing any type of chart in it. So if you say the value of G here, that's the container holding this guy. Okay, sorry, container holding this guy dot map plt.scatter. So it's going to give you a scatter plot. You know, initially if you do peer plot, if I do sns dot peer plot and I put in Iris, I'm going to have a peer plot. Okay, I'm going to have a peer plot, which is this. Okay, but when I do for peer grid, it's more advanced. So we don't get we don't get the map unless we specify the kind of chart we want. So you could do plt.scatter, you could do gmap.histogram, you could do histogram, you could do scatter, you could do KDE plots. So now for this now I say gmap.diagonal. So the diagonal aspect of it is having the histogram, the upper aspect of it is having this upper aspect, just like this, is having the scatter plot, while the lower aspect is having the KDE. So from everything down here is having the same kind of plot. So let's move to peer plot. So for peer plot, now for peer plot, if you look at this plot, it's showing the summary of the data set. The diagonal, when you try to look at petal width and petal width, okay, you kind of see the kind of close chart, but not the same thing exactly, but they have similar looks. Okay, like this one, petal length with petal width, and you come here and see petal width and petal length. They just swap each other, petal width, petal length, and petal width, petal length. So for here we have petal width, for here we have petal width. Don't forget the petal width here is what is here also. That is this place. So petal width, petal length, and petal width down here, and petal length at this place. Okay, so that's why we have kind of similar plots here. If you look at some plots are turned upside down. Okay, some plots are kind of upside down and they kind of not look alike, but are turned upside down. Let me just find one for us. Okay, I think this and this are kind of look alike. So the OSS is just to show the relationship between the difference. You could read about peer plots, how to interpret a peer plot, and that's assignment number 3. Yes, I told us assignment number 1 is to get more types of palettes, color palettes in Seaborn. Assignment number 2 is to get more color types for CMap in each map or cluster map. Then the third one is to how to interpret a peer plot. Okay. So now let's look at peer plot. So for peer plot, we are featuring with species. And the palette is rainbow. Now you see we are using another palette, rainbows. Okay. So now let's talk about fixed grid. For fixed grid, we are still using the same data set called tips. Okay, so if you do just the way we have peer grid, if you do fixed grid and you just pass it like that, you're going to have an empty canvas. Okay, but if you say G equals to gmap plt.hist, that is histogram plot, then you're going to have something in it. Okay, so the tips here, the column is time, the rule is smoker. Okay, and for fixed grid, you could say plt.scatter. Over here we use histogram, plt.hist. Here we say plt.scatter. We said .add legend. So at the end it added a legend for us. Over here too, we could say .add legend, but we didn't filter anything. It's just plain. We didn't filter anything. Over here we'll filter by sex, either male or female. Okay. So same thing applies to joint grid, sorry. For joint grid, same thing. You have to specify, so we say gplot, snn.rog plot, snn.displot. So we're going to have a rog plot. So now let's talk about regression. So for regression, you just do LM plot. LM plot just has to do with linear regression, kind of. Okay, allows you to split up those plots based on features as well as crawling the U based on the features. So you have a linear chart. You could Google the different kind of linear graph. We have positive and negative linear graph. So this is a positive linear graph, okay, showing from left to right. how. So if the dots are well placed on the line, you'll be able to know that, oh, this is a linear graph or not. But this is a linear graph because it moves across the dots. Okay, so over here we just filtered by hue, which is the gender, and it gives us a colorful design. Okay, then LM plot, same thing. The palette now we are using is color one. Okay, so now let's work with markers. Okay, we could change the dots and we could separate them, we could change them. Just use markers O, V, and scatter plot S, that's the size, to 100. Okay, so the size of this stuff is 100. Okay, so it's just a repetition of what we've done, and I think that's all. So we could okay, yeah, there's an aspect size also, and size, that is the size of the plot, how many occurrence you want it. Okay, like this one I will set 1, 2, 3, 4 because we are dealing with the column day, that's Thursday, Friday, Saturday, Sunday. Then the size is 10 and the aspect ratio is 6, sorry, 0.6. Okay, so if you have any question regarding this, please let me know. And if you feel like you don't understand some things, you could ask or you could Google it. Okay, Google is our friend. You could, let's say you're having issue with the code that is not running, or you don't understand an aspect of the code. The Seaborn documentation is there. You could, in fact, there are galleries. What I do most times is if I like a plot in here, okay, I just tweak the code and fit in my, as long as my data is in line with what it is, because if your data is not in line with the plot, sorry, if your data is not in line with the plot, you won't get it at all. You won't get that plot. Okay, so you could try out, you could check more on that gallery and see more different kind of plots. We have line plots. Let's talk about line plots. So for line plots, we have these. Okay, so I think that's all. So we have an exercise for us to do here. So please carry on with it. And if you have any question, please let me know. All right. So thank you very much, and have a lovely day.